Good morning students, I am Rajesh from CSC department. So today we need to discuss module 1 in unit 2. So the topics are data and signal. So next one is the bandwidth limited signals and Fourier analysis. So before going to this topic we need to discuss unit 1 once again. In unit 1 we are divided into 6 modules. So each and every module having what is internet, introduction to internet, and what are the networks we have having network topologies, network topology in the sense how the network is established by using bus topology, by using star topology, by using mesh topology, by using hybrid topology. So these are the topics we are under network topologies. And coming to the network types, LAN, WAN, MAN, local area network, wide area network, metropolitan area network, and coming to the network models. So by using network models only we can transfer the information from sender to receiver. Okay, we have so many network models are available in our internet network, but in our syllabus we are discussing only 2 network models. The first one is the OSI reference model. OSI in the sense open system interconnection. It is established by the ISO in the sense Internet Standard Organization. So with the help of ISO organization, so OSI is introduced. So OSI contains 7 layers. So those are application layer, presentation layer, session layer, transport layer, okay, so network layer, data link layer, and physical layer. Each and every layer do particular task. So every layer have 3 responsibilities: information or data getting from the upper layer. Okay, so after getting the information, it can convert the information as the layer requires. After confirmation, after completion of task, the data is transferred to the lower layer. Okay, so each and every task followed by some protocols, some algorithms. Here, what is meant by protocol in the sense? The protocol is a set of rules and regulations. Okay, by using these rules and regulations only, we can transfer the information, we can transfer the data from one layer to another layer. Okay, so coming to the TCP by IP. TCP by IP is the transmission control protocol. So through IP address, it is one of the network model in our computer networks. So by using these network model also, we can transfer the information, we can transfer the data from sender to receiver. Okay, so coming to the TCP by IP, so TCP IP having only 4 layers. The first one is the application layer, and second one is the transport layer, and third one is the internet layer, and fourth one is the host to host layer. Okay, so here also each and every layer have some 3 responsibilities. So getting the information from the upper layer and convert the information, and after conversion, so it transfer to the lower layers. Okay, so and another topic is comparison between the comparison between the OSI reference model and TCP by IP. So there is a lot of differences between the TCP by and OSI model, TCP by IP and OSI reference model. So these topics are discussed in unit 1. Okay, so module 1 introduction to computer, module 2 network topologies, module 3 LAN, WAN, MAN, and module 4 TCP and OSI reference model, module 5 TCP by I network model, and 6th module is the comparison between the OSI reference model and TCP by I reference model. Okay, so this is about unit 1. Coming to the unit 2. So in unit 2 we are discussing mainly 3 topics. Okay, the first one is the data and signals. In this data and signals we are discussing bandwidth limited signals, Fourier analysis. Okay, Fourier analysis, and coming to the and second topic is the transmission medium. So what is meant by transmission medium and how it works in the sense? Transmission medium is divided into 2 categories. The first one is the guided transmission medium, and second one is the unguided transmission medium. So this is the second topic, and third topic is the services provided to the data link layer. So now we are in physical layer. So we have to provide the services to the data link layer. So these are the topics we have discussed in unit 2. So but today we are discussing module 1. In module 1 here, what is data and what is signal, and coming to the another topic, what is bandwidth and what are the limited signals of bandwidth, and what is meant by Fourier analysis. So these are the topics we are discussed in this session. So now we have to briefly discuss the topics here. What is meant by data in the sense? Data is a collection of information. Okay, the information is depends upon the particular the information is depends upon the environment. Like so data can be stored in the form of bits. Data can be stored is in the form of frames. Data can be stored is in the form of packets. Data can be stored is in the form of segments. This is about data. And finally, data is we already know that data is a collection of information, right? So data is mainly divided into three categories. The first one is the structured data, and second one is the semi-structured data, and third one is the unstructured data. Here, what is meant by structured data? So structured data in the sense there is a structure in the among the data. There is a structure in this data. Like we are using multimedia files. So images, audio, video. Images contain several formats: JPG format, okay, PNG format. So or else so audio having also so many formats: MP3, MP4, and video having also so many formats like AVI format, VOV format, MP4 format, so MKV format. These are the formats of the video. Okay, so these are the structured data. Coming to the semi-structured data, here we are using log files. Okay, if you log in into the Gmail, definitely we need one login ID. So @gmail.com. If you log in into the Yahoo, so there is a definitely we are having so one login ID. So @yahoo.com. So followed by the password. The password is under dots like that. Okay, these are the semi-structured data. Coming to the unstructured data, so there is no structure. So the best example for the structured semi-unstructured data, text files. Okay, so we are using some editors in our computer. So Notepad, WordPad, document. These are the unstructured data. Coming to the signals. Here, what is meant by signal? Signal is the process. Okay, signal is the process. By using these process only, we can transfer the information from sender to receiver. And coming to the bandwidth, so here bandwidth in the sense, so every internet having one bandwidth. So based upon the bandwidth only, we can increase the net speed. Okay, so there is a limited signals also available. And coming to the Fourier analysis, Fourier analysis is act as a one vice versa. Okay, so these are the topics we are discussing in next slides. Okay, so coming to the next slide. So there is a node. So that node is so data can be transmitted. Definitely it can be transmitted. So but data must be transformed to electromagnetic signal. Here data definitely transformed, but so it can transform to electromagnetic signal. So what is meant by electromagnetic signal in the sense? So you all are EC students. Definitely we know this information. So electromagnetic signals is a very huge syllabus. So we all know about electromagnetic signals. So that's why I'm moving next slide. Okay, so coming to the analog and digital. Here, what is meant by analog and what is meant by digital? So analog in the sense, analog or digital is both are the signals. Okay, so data can be transmitted. So analog or digital. So data must be in the form of analog data and digital data. Here, what is meant by analog data in the sense? The term analog refers the information to information that is continuous. So analog is a continuous information. Okay, so but digital is a distinct state. So it is the information that have the distinct state. Okay, there is no continuous state. There is a distinct state. Okay, so coming to the another point. So analog data takes an continuous value, but digital data takes an distinct values. So we all know about what is analog information, what is analog communication, what is digital communication. Okay, so but here in this computer networks, so there is no what you call. So we don't want to concentrate this topic very much. Okay, so that's why I'm simply says analog is nothing but it is a take the information and continuous format, and digital is take the information but it is a distinct format. Okay, so coming to these are the topics we have discussed in this session. The first one is the analog and digital data, and second one is the analog and digital signals, and third one is the periodic and non-periodic. Okay, these are the points we have discussed in this session. Okay, the first one is the analog and digital data, and second one is the analog and digital signals, and third one is the periodic and non-periodic signals. Okay. So the first one is the analog and digital signals here. So there is a 3 points of these analog and data signals. The first point is data can be analog or digital. So we already discussed in previous slide. So definitely data can be is a form in the form of analog or digital. Okay. Second point is the analog data are the continuous and takes continuous values. Okay, so it is a continuous process and it takes a continuous value. There is no exact value for the analog communication. Okay, so coming to the digital communication, so digital data having distinct state and take distinct values. Okay, so there is a exact value we are taking from the digital communication. Okay, so this is about analog and digital data. Coming to the analog and digital signal, this is the second topic we are discussed in these topics of analog and digital signal. Here, what is meant by signal in the sense? Signal is a process. By using these process only, we can transfer the information. So from one end to another end, data can be transmitted. Is in the form of electromagnetic signals. So we already discussed electromagnetic signals is a very huge topic. Okay, so this information is discussed on earlier slides, earlier topics. Okay, so in this session also we are discussing 3 points. So topic also we are discussing 3 points. The first one is the signals can be analog or digital. Data can be analog and digital. Signals can be analog and digital. So what is the diagram? Where is the diagram for analog? Here is the diagram for digital. So these diagrams are given next slides. Okay, and second point is the analog signals can be infinite number of values in a range. So it can produce infinite numbers. There is no finite numbers. There is no limit. There is no exact value. So it produces continuous process. That's why it can produce infinity numbers of value in particular range. There is if you are using one range, in one range also it can produce infinite numbers of values. Okay. Coming to the next point, so digital signals can be having limited number of values. By using digital signals, by using digital communication, we can get exact value from the what you work. Okay. So these are the 3 points we are discussed in this topic: analog and digital signal. So comparisons of the analog and the digital signal. So this is the diagram for the analog and digital signals. So here coming to the analog signals. So here there is a graph, x-axis and y-axis. So x contain time, it is a timeline, and y contain value. So values in the sense 0, 5, 10. So this is the values of the y-axis. So there is a signal. So the signals is in the form of wave format in analog signals, and this is the continuous format. Okay, but in this diagram there is no exact value taken from the analog signal. Okay, so this is the diagram. This is the graph for the analog signal. Coming to the digital signal, so digital having also one graph. This is the timeline and this is the value. So here we are using time slots. Okay, here we are using time slots. By using digital signal, it can produce exact value. So this analog, best example for the analog signals, if you ride any bike, so old bikes, there is an analog meter. So 0, 10, 20, 30, 40 is the meter, analog meter. So there is no particular speed we are maintaining in analog signal. By using analog signal, we cannot find on particular speed limit. We cannot find in analog signal, but in digital signal, so we find the exact value where we have. Okay, so this is also timeline. So by using timelines, so there is we are using time slots too. So to communicate from sender to receiver. Okay. So there is another note for the. Another note. So the note is if a signal does not change at all. If a signal does not change at all, its frequency is 0. All of you know about this rule. So there is no change in signal in long time. The frequency is 0. The frequency is under 0. But the signal changes instantly. So first phase one signal, one signal type. Second phase automatically it changes to another. Third phase it changes to another. So in this situation, so the frequency is infinity. Okay, this is a very important note. Please note it down. If a signal doesn't change at all in a process, its frequency is 0. So if a signal changes the instantly, so then the frequency is infinity. Okay, so here there is another diagram. So here there is a wave with, so we are using sine wave. We are using sine wave with same amplitude, same frequency, but different phases. Okay, we are using 0 degrees. Okay, we are 0 phase, and we are using 90 phase. We are using 180 phase. So these three phases we are using same amplitude and same frequency. So there is what is the difference for phases? So here we are using 0 degrees. This is the sine wave. Here also we are using timeline, and this is the value y-axis, and this is the time for x-axis. So by using in 0 degrees, it starts from 0 and starts. This is a sine wave. So here we are using same amplitude and same frequency. Okay, so coming to the 90 degrees, in this 90 degrees we are using in, so 1/4 timeline. Okay, so here also we are using same amplitude and same frequency. This is also sine wave. Okay, so here also time, and this is the value. So it can produce same amplitude and same frequency in so different phase 90 degrees. So coming to the 180 degrees, 180 degrees in sense, so is a half time limit. So it go to the sine wave is in the form of like that. Okay, so these are the differences between phases: 0 degrees, 90 degrees, and 180 degrees. So these are the differences between the sine waves. So but amplitude and frequency is same. Okay, so coming to the Fourier analysis. So here there is a one note for the Fourier analysis. So Fourier analysis is act as a vice versa. Here what is meant by vice versa and what it do? Okay, here, so before going to the Fourier analysis, I want to discuss one topic. The topic name is a compiler. Here what is meant by compiler? In the sense, compiler is a translator. Compiler is a translator. Why we are using translator? Because human understandable language, nothing but high level language. Machine can understand understandable language, that is called binary language, zeros and ones. Okay, human doesn't know about machine level language, machine doesn't know so about high level language. In that situation, we are using translator. So by using the translator, we can transfer the information from high level language to machine level language. So after conversion of high level language, machine is fully understanded what the instruction passes by the user. So and after completion of the process, it produces one output, but the output is in the form of machine understandable language. So the machine understandable language doesn't know by the user. So in that situation, again compiler do the same thing, is a vice versa. So machine level, first initially it starts the high level, it starts the converted the information high level language to machine level language. In the sense, alphabets or numerics to zeros and ones. After completion of process, after producing the output, so the output also is in the form of binary, zeros and ones. So user wants to understand the zeros and ones. Here translator, here compiler do the same thing. So from machine level to user understandable language, and nothing but high level language. So this process is called vice versa. Here also Fourier analysis doing same thing. First of all, Fourier analysis is a tool. It's a tool. By using this tool, we can change the time domain signal to frequency domain signal. Okay, we can change the time domain signal to frequency domain signal. At the same time, after completion of all job, so it can convert the information, it convert the frequency, it can convert the signal to frequency domain signal to time domain signal. Okay, so here what is meant by time domain signal and what is meant by frequency domain signal? These are the topics we are discussing in next slides, next topics, next area sessions. Okay, so this is the information regards Fourier analysis. And coming to the example for the Fourier analysis, this is the Fourier analysis diagram. So the first one is the time domain. Okay, here so S of t is equal to a0 if t less than or equal to lambda by 2. So otherwise like that. Okay, so these are the information regards example for the Fourier transform. So it can transfer the information from time domain to frequency domain, and after completion of process, so if any occurred, the Fourier analysis do same thing. So vice versa operation, frequency domain to time domain, like that. This is the timeline, and this is the frequency in the form of lambdas minus 3 lambda, like that. Okay, so these are the information regards Fourier analysis or Fourier transmission. In this session we discussed mainly what is data and what is signal, what is analog communication, nothing but what is analog data and what is digital data, and what is analog signal and what is digital signal. And coming to the next one, and another one is Fourier analysis is comparison between the analog signals and digital signals, and we are using sine waves, but we are using different phases, 0 phase, 90 degrees phase and 180 degree phase, but amplitude and frequency is same. Okay, so this is the information regards. So after completion of this topic, we need to discuss transmission medium. So here transmission medium is very important for the communication purpose. Why? Because every sender and every receiver wants to send the information, wants to receive the information, so through transmission medium only. So transmission medium is like a bridge to sender and receiver. So bridge is a bridge. Why you are using bridge? So bridge is used for the communication. We can use the communication purpose. We are using bridge. Okay, so transmission medium also doing same thing. It acts as a bridge for communication between user and receiver, means sender and receiver. Here there is two types of transmission mediums are available. The first one is the guided transmission medium, and second one is the unguided transmission medium. So these topics are discussed in earlier sessions. Okay, I hope all of you understand this topic. So thank you.